Welcome, welcome, Dan. Dan joins us from the UK. Daniel Jaevons works currently with Shell Corporation in the US, in the UK, in the digitalization department. His work and the initiatives taken by the Shell Corporation is very significant. Digitalization, how it is going to be applied, and artificial intelligence technology on the energy sector. It's going to be a game changer with regards to digital solutions in the energy, including the oil and gas sector. The energy transition and the digitalization are the two key mega trends that will affect the world. And I'm sure what we are going to hear from Dan is going to be absolutely a futuristic application of how uh, new technology platforms can help in optimizing energy, especially the existing assets as well, how they can be more operated better efficiency. So the subject is quite new to all of us, Dan. So I leave you to present us what's going on in the digitalization.
Super. Great. Well, as I said, thank you so much for having me. I'm just going to share my screen. Dan Jaevons. I'm the General Manager for Data Science here at Shell. And my role is to look across all the work that we're doing in data science and AI globally. So I look after teams that are based in the US, in the Netherlands, in the UK, and also over there in India, based out of Bangalore. I've got a keen interest in India. I spent a lot of time there, so it's great to be with you. And obviously India is a key market for us and an area where we're investing heavily because of the energy needs, but also some of the environmental needs that you all have. And so I'm going to talk a little bit about that. I guess what I wanted to share today was maybe four key things. So the first thing is sort of building on what Shankar was sharing. I firmly believe that there are two major trends that are going to utterly transform the way in which things happen in the coming decades. One is energy transition. I think we've all seen that with the COVID pandemic and all the challenges that we've had around that the pace of energy transition has picked up. The commitments that companies have been making to accelerate their ambitions to get to net zero. We see those all the time. Most recently, I saw one from Infosys in India. So we see that happening in India too. And of course, digital. Digital has been a growing mega trend, and in particular, AI is now becoming mainstream and is having a huge impact on many companies, but also in particular on the energy sector, where perhaps some of these technologies have been less applied historically, and we see that accelerating. And I guess what you see in Shell is a microcosm of all of that. So we have obviously a huge transition going on in the way that our business is run and the things we're focused on. And at the same time, we also have a massive transformation in terms of digital technology going on. And so what I want to talk to you about today is really the way in which we're applying that. And I really want to leave you with one key message, which is, for me, the key about digital and AI technology is that it's both an imperative for our current business to make the way that we do things more effective and efficient. And I'll give you some examples of how that is happening, as well as also very much an opportunity because it's going to be critical to our new business. And it's also going to make sure that business runs much better in the future than it does today and very differently. And I hope to paint a picture of that. And finally, I also want to talk about the fact that openness is very much the foundation of what we want to do. We can't do this alone. We have to do it as part of an ecosystem. We have to do it with partners. We have to do it in a way that brings together academia, industry, society, startups, and the like. And I'll talk about some of the ways in which Shell is trying to do that. So a quick cautionary note, just basically saying, please don't invest in any Shell shares on the basis of what I'm going to say today. Very much sharing my own thoughts and opinions here. So let me just give you a sense, first of all, of how quickly digital transformation is happening. And I'm using Shell here as the example. Over the past few years, we've really seen a step change in the adoption of digital technology. And these are some of the current metrics that we have going on across our organization. We've got over 50 AI-powered applications that have been deployed now across our organization, which are impacting on all sorts of our parts of our value chain, right from operations, so operating our traditional assets, our manufacturing plants, our upstream facilities, right through to impacting the way in which we run our retail stores globally. I think over 48,000 of those now. We also have huge volumes of data being aggregated. We've recently aggregated over 1.3 trillion rows of sensor data across all of our facilities, bringing in our global footprint and trying to understand all of the activities across all of the sensors that we run in all of our facilities every day. And of course, this creates a huge opportunity for AI and machine learning. And we've got about over 5,000 pieces of equipment today being monitored using machine learning. And that's up from about 100 this time last year. So if that gives you an idea in the step change and the speed of acceleration that's happening as we bring together these volumes of data, you can see an exponential growth curve in our ability to deploy and manage AI models online. Similar story with drone missions. So I think, if I'm not mistaken, we were in the hundreds at the start of last year. Now we're over 1,200. And of course, having to operate assets virtually as we have had to in the last little while has accelerated the adoption of these technologies. And we have now, and you can see videos of this if you look online on the Shell.ai pages, we have robots and drones doing cleaning jobs, running inspection rounds and identifying issues such as small, very, very tiny leaks within the plants, which previously may have gone undetected. And so those sorts of opportunities using that sort of technology is really absolutely fantastic. We've seen 10x adoption of virtual rooms powered by augmented reality, where we have remote inspectors logging into these rooms to see what's going on in the facilities. We've issued about 31 million rewards using an AI-powered system in our retail loyalty systems, and we've got about 1.7 million users registered to that. And we've got about 350 people now who are working in this space, researchers and data scientists, as well as AI engineers across the organization, and about 800 citizen data scientists, people who have been trained up in the business to be able to use some of these technologies to solve everyday problems. So just gives you a sense of the breadth and the huge scale of the opportunity that we see. And as I said, this is both having an impact on the efficiency and the effectiveness of our business, but it's also having an impact on I guess, the environmental impact of our facilities as well. So this goes both good for business and good for the environment. And I'll give you some examples of that. I mean, the predictive maintenance one is perhaps an obvious case. Of course, as many people know, when things go wrong with machinery, it has a number of negative impacts, both business-wise in terms of productivity, but also environmentally. We may have emissions coming from that. We may have disastrous breakdowns, which then lead to people having to fly out to facilities to solve those problems, and of course, replace large pieces of equipment. And obviously, if we can find small and fix small, we can mitigate all of that impact. And so we've been rolling out a global proactive technical monitoring program, which allows us to monitor all of our facilities virtually all of the time, 24/7, from 2 global locations, mainly one in the US in New Orleans, and the other actually based in India, in Bangalore, which we call the Arch. And so we're now infusing our AI-driven approaches into that proactive technical monitoring through all of that data aggregation that I talked about earlier on. And we're using that to find anomalies, and we're finding some phenomenal things and preventing things which otherwise would have had significant impact on our business and also potentially in some cases, sadly, the environment. But gladly, we're now able to stop that and prevent that by catching it early and then arranging intervention. So that's one example. Similar example in the optimization space, we are now rolling out optimization technology that allows us to optimize the facilities of our LNG plants. Now, in the first instance, this is good for business. As I said, it's allowing us to increase more LNG from the facility, about 1 to 2% production increase. But I also wanted to flag here that this also has a CO2 impact. And many of you who have an optimization background, and I know with many of the engineers on the line, that will be the case, you'll understand that as you look at these systems, you can figure out pretty easily how to both reduce the CO2 emissions by effectively changing some of the set points and looking at some of the parameters, and obviously still operating those things safely. And also at the same time, look at how the CO2 is generated and look at ways in which that can be mitigated. And so that's been a big project for us, and we've seen significant opportunities. And we see more of that going as we go forwards, because we're also rolling out digital twins to all of our facilities. And those digital twins really have the capability to bring together even more data and help us understand in even more granularity what's going on at every part of the facility, and use that to minimize the environmental impact. And I think this is obviously highly relevant to the energy industry, but I think these approaches are also relevant to all forms of heavy industry. And we're now starting to work with our customers to try to see how we can bring some of that to them. And I'll pick that up later on in the presentation. But I talked about openness at the start, and the importance of openness. And in many cases, we recognize that many of the processes that we run today need to be monitored, often by external regulators, often by other parts of the business. In the case of groundwater monitoring, which I thought was a good example to share with you, it's sort of all of those things. We have external consultancies that come and look at the groundwater underneath our assets and our sites. We need them to submit their data in a consistent format. We need to perform consistent analysis on that. And we need to be transparent with the regulators and also with the environmental consultants within Shell to make sure we're making the right decisions. I think the amazing thing about this example, I think it's an example of the way we have to move forward, is total transparency and open source. And so we've worked with the University of Glasgow to develop what we built internally, which we call GWSDAT, as an open source framework. It's now been adopted by the UK government, also in the US as well, and it's growing elsewhere. Many companies have adopted this as a standard. And effectively what it is it's a tool that creates consistency. So when we say this is the environmental impact that we see, and we're going to do this to address it, it's completely transparent to the regulator that that is the case, because we're using the same framework to analyze those results, the same data science, and all of that has been subject to audit and review, and it's done in a transparent way with an academic institution. And I think this is much more the way in which we're going to have to do things going forwards. I also talked about new business models, and I think with any huge transformation, as we look towards energy transition, we see that there's going to be a change in business models, and we're going to have to work with we're going to have to create new ways of making money, and we're also going to have to work with our customers in new ways. And so I thought I'd share a couple of examples of how we're already doing that. At Shell, we believe one of the key elements to mitigating many of the impacts around climate change is going to be carbon capture, utilization, and storage, and actually putting carbon in the ground as much as we possibly can rather than generating emissions. And I think that ties very closely to the theme of this session. But of course, what we also recognize is that AI is going to be key to that, because we need to verify that what we put in the ground stays in the ground, and we need to be able to do that in a way that regulators are satisfied that that's the case. And so we've been doing this already at scale in the Quest facility. We put over 1 million tons of CO2 per year into the ground at Quest. And we use AI to monitor that both above the ground and beneath the ground increasingly. And we're working hard to make sure that those frameworks are robust. You may have also heard we've committed to a new program where we're trying to model a whole supply chain around the carbon capture and utilization and storage opportunity. And so we're very much focused on that and trying to make sure that that is going to emerge. We're using the Northern Lights program, which we're working with Equinor and Total on, to try and demonstrate that integrated supply chain. And digital technology is going to be key to that. We're partnering with Microsoft to develop that technology, and we see that as a huge opportunity. And then in our customer space, we're also working with many of our heavy industrial customers to roll out similar technologies to the predictive maintenance technology that I talked about earlier on, to help them improve the monitoring of their processes. And one element is lubricant monitoring. Many of you will know that lubricant monitoring is a very effective way of identifying issues with machinery. And so we've packaged that up into an offering which we call Shell Remote Sense, and we're rolling that out to a number of our customers already. But of course, all of that's not enough. We also see that there's going to be a huge impact and a huge need to totally transform the way in which we generate energy. And so I thought I'd talk very briefly about 3 examples of that as well. We're working very hard on electric mobility. We've rolled out to date over 165,000 electric charge posts through our partner companies, or our wholly owned subsidiaries, I should say, Greenlots and New Motion, as well as rolling out stations, similar charging stations at our retail forecourts as well. And so we see that charging infrastructure growing exponentially. And as we do that, of course, we need to make sure that it's cleaner. And cleaner means that we need to make sure we maximize the use of renewables as much as we possibly can, because that's the whole purpose of, or one of the main purposes of moving to electric vehicles. And so to do that, we need to be able to optimize the way in which these vehicles are charged. And particularly at the home, making sure we take advantage of points in the day when the maximum amount of renewables are on the grid. So we've developed sophisticated optimization algorithms, which we call smart charging, which allows us to optimize the way in which these vehicles are charged. Similar scenario in the hydrogen domain, where we're increasingly rolling out hydrogen to our retail stations, but also as part of electrolyzer projects more globally. We've got a huge one which we just committed to in Rotterdam. And the key point around these projects is that a lot of them are new processes. We need to develop hydrogen infrastructure. We need to develop the solutions around how that can be scaled. And we rely heavily on combinations of physics-based models and AI to allow us to scale that up. And then, of course, we also have, we're also investing heavily in wind technology. And as we do that, we need to optimize the layout of these sites to make sure that they are on as much as we possibly can make them, that they generate the maximum power output, and also that they're combined with things like hydrogen and battery technology in effective and sophisticated ways. And again, there we rely heavily on optimization technology, on physics-based models to understand that, and then to design the way in which we're going to roll out these wind farms, and then to make sure that when they're operated in the most effective way. So very similar to some of the optimization approaches that I talked about in our traditional facilities, now being applied in the wind domain. And I guess building on that theme, I also wanted to make clear that we're not trying to do this all by ourselves. I talked about openness. And I think the key thing here is that we are trying to work with partners in academia, with startups, and many of them in India, to try to bring in the best ideas, because these problems, these environmental problems, these energy problems, which we have as a society, are not easy problems to solve. In many cases, we believe the technology is not fully there. And so what we're pushing for is a number of approaches whereby we can bring in brains like yours to work with us to help us to try and solve some of these problems. So last year we ran the wind farm layout optimization hackathon. If you haven't seen that, maybe check it out online. It's available on our website, and also you can find it on LinkedIn if you search back through posts. The key thing about that optimization hackathon is we've tried to particularly focus on India and ask some of the brightest minds to come and look at some of our data sets and say, what are we missing? What are the better ways of approaching this problem? We got some fantastic results from that. And we're trying to repeat that this year with Game Changer, again, looking at waste management and how we can help frontline waste workers, again, particularly in India, with solving some of those really tough challenges that you face, and trying to open source, again, some of the data sets that we have around that. And then I think we also have a startup program called E4, where we run annual cohorts of startups, which we bring in. We invest in those startups, we mentor those startups, and we look to try to accelerate the scale up of those startups, in particular in the energy sector. And of course, we also are trying to build in-house capability. We've recently rolled out the residency program in India to try and bring in the brightest minds into Shell to work with us on some of these really tough problems. So I'm conscious of my time. I just wanted to say, to summarize, I've covered a lot of ground very quickly. And of course, you know, what I wanted to do was give you a flavor of all of the things that we're trying to do right across the value chain in around 20 minutes, just to give you a sense of the way in which we're approaching these problems. But just to kind of bring you back to the main points, as I hope you'll agree with me, digitalization and also energy transition are two hugely important trends that we need to address as society, to embrace and to take on and to embed into the way that we do things. And that's not easy. To do that, we recognize that we've got to play our part, and we're investing heavily in digital and AI as part of making our existing operations more effective and efficient, trying to minimize the impact of those, and also in trying to develop new technologies that are going to shape the future energy system. And I guess to re-emphasize, openness is foundational to what we're trying to do. We want to work with partners, with academia, with startups, with society, because we recognize these problems are not easily solved, and we need to do it together. So with that, apologies for the technical problems. I hope we got there in the end, and happy to answer any questions if we have some time.
Very interesting, Dan. You have clearly eliminated the human intervention in gathering data and analyzing it. It's all very transparent in digitalization and artificial intelligence, which gathers the data in a uniform way. My view is that you could work more closely also with the regulating authorities, because most of the assets that they perform, if there is a malfunction, the regulatory authorities also have to intervene to ensure that the corrective actions are taken appropriately at the appropriate time. So it's not only the monitoring, but it also the ensuring that the corrective and preventive actions are taken to an open and transparent digitalization. That's also a great application I can foresee.
Absolutely.
There are some questions from our audience. We can take on to Dan.
Yeah, I think he touched upon the digital twin concept. I just wanted to know what are those areas where digital twins are being used by Shell, and to what benefits?
Yeah, great question. And I think maybe just to start, I think the challenge, digital twin is one of those terms that means a lot of things to a lot of different people. Yeah. What we talk about is the fusion of both data and models that represents the physical reality of the asset that we're talking about. So it's for us, it's very much data and models coming together. I think up until last year, we'd been very much in the experimentation phase. We've now completed our first full-scale deployment of a digital twin, which we did at the Nyhamna gas plant in Norway. And it's a phenomenal thing. We've really demonstrated that we can integrate all of the historical documentations, engineering documents, diagrams, the sensor data, the real-time information flowing from the plant, from the actual DCS system as well. And we've integrated all of that into an integrated platform which can be queried and explored and used as part of the day-to-day operations of the plant. And that's been absolutely fantastic, just a real step change for us. We're now trying to build on that success and replicate a similar approach globally. We are working hard on trying to roll it out in Trinidad and Tobago. We have several other assets on the roadmap this year. And the plan is to gradually scale up across multiple assets globally to full-scale deployment in around 18 to 24 months. Now, as I said, we're building on a lot of things we'd already done. We'd already brought together a lot of the data that we needed. And we're now trying to just create an additional framework. I think the huge opportunity is to, once you have that digital twin, is in that optimization domain, where a lot of the scenarios we're looking at is how could you run all sorts of what if scenarios across the asset, and then try to understand what the impact of that would be before rolling it out, and allow people to do that real-time testing without having to run actual experiments. And I think that is extremely exciting and very, very powerful as we look to have an impact on some of the things I was talking about today.
Right. Very exciting.
Very exciting next generation applications on digitalization, particularly on energy management and waste conservation and pollution control. Any more questions from the audience before we move on to the next speaker? Because this is a very interesting subject.
I just wanted to know if we can read somewhere about how is it a game changer on waste management. If you could share some literature, some website.
Yeah, I'm absolutely happy to do that as a follow-up for this community. No problem. I'll get you all of the latest information. We're sort of in between calls. The wind farm layout hackathon has happened and finished late last year. The next one will be on waste management, and that's just being framed up. But I'll get you the information on that. And obviously we'd love students from.
Yeah, well, I'm not exactly a student, but one, teacher is also always a student.
Teachers are also very welcome.
Yeah.
Look,
But
even better. Absolutely.
Some AI, artificial intelligence or machine learning for my data analysis in high energy physics. So it would be interesting to see how you do it for waste management.
For sure.
Thank you.
Right.
Happy to share.
So thank you, Dan. It was a very exciting to see that the next generation of asset management through very transparent way of digitalization. So we look forward to receiving more input from you so that we get to see more applications in India that we can leverage the application that you have already optimized and presented to rest of the world. Thank you, Dan.
Super. Thank you so much. Thanks for having me.